Hello, this is Miss Teasley here. We're going to start Unit 2 today. Today is Thursday, February the 6th, inclement weather day, so we're going to go ahead and just move on to the next unit. The test will be postponed until Tuesday. Alrighty, so let's fill in this information. So you can find these notes on Blackboard. Go ahead and download Unit 2 notes. You can go ahead and download all the unit notes for the future, but we're starting Unit 2. The name of this section is Linear Equations. So let's fill this in. A number that makes an equation a true statement is called a solution of the equation. The set of all numbers that satisfy an equation is called the solution set. Of the equation. Equations with the same solution set are equivalent equations. Right, just want to fill this information in. Basically what this middle part is saying is that whatever you do to one side of an equation, you must do to the other side. So basically, if you add a number to one side of the equation, you have to do the same. I'll talk about that as we solve equations. So the first type is just solving a linear equation. So your goal is to isolate x. You want to get x by itself on one side of the equation. So what I'm going to do first is get rid of the parentheses by using the distributive property. So I'm going to distribute -4 to that parentheses. So that gives me -12x plus 20 equals 3. There is an imaginary 1 in front of that parentheses that we don't see. So we have to distribute this -1 by multiplying both terms in the parentheses by -1. So this is -8x minus 7. At this point, I'm going to combine like terms. So I have -12x plus 20 equals -8x. When I add 3 and -7 together, I get -4. Again, your goal is to get x by itself. So you want to get x on one side of the equation and the number on the other side. So what I'm going to do to get rid of a minus x, I'm going to add, in order to get rid of a minus 8x, I'm going to add 8x. But what you do to one side of the equation, you got to do to the other. So I'm going to add 8x to both sides of the equation. It cancels out on this side. -12x plus 8x is -4x. I'm going to bring down that plus 20 behind it. And that equals -4. Now that I have x on one side of the equation, I want to get rid of that plus 2 behind it. So I'm going to do -2 to both sides. So that's -4x equals, when you add -4 and -20, you get -24. At this point, to get x by itself, that's -4 times x, all right, because they're side by side. So to undo multiplication, you need to divide. So I'm going to divide both sides by -4. So when I cancel out the -4s, I get x equals -24 divided by -4 is +6. That will be your answer. All right, moving on to the next equation. These are equations with fractions, and no one likes fractions. So we're going to try to get rid of all the fractions so that we have a nice linear equation like the last example. So I'm going to rewrite this over here because I write a little big. 3x plus 6 over 10. Leave a little bit of space. Minus 1/2 x equals 2 over 5x plus 33 over 5. So actually, what I'm going to do is all the x that you see beside the fractions, those actually go to the top beside in the numerator. So you actually can move the 1x. You actually can move this x, circle it. See if I can get it to. I can move this x. Oh, that's not working out. Move this x right here beside the 1. And then the same thing, I can take this x beside this fraction and move it at the top beside the x. So the x can go right beside the number in the numerator. So your goal is to get all your denominators to look alike. You want them all to have the same denominator, and then we can drop it off. So what I'm going to do is I ask myself, what number can 10, 2, and 5 all divide into? And the number would be 10. All right, 10 is what we call the least common denominator, or LCD. So I'm going to do whatever it takes to make all of my denominators a 10. So the first denominator is already a 10, so I'm going to leave it just like it is. When I get to my second denominator, if I multiply 5 times 2, all right, that will turn this into a 10. But what you do to the bottom of a fraction, you got to do to the top. So I'm going to multiply this top by 5 also. When I get over here to the other side of the equation, I'm going to multiply this 5 by 2 because 5 times 2 is 10. But again, what you do to the top, what you do to the bottom, you must do to the top. And then when I get here to this 33, multiply the top and the bottom by 2. So in this next step, I'm going to rewrite everything. All right, so this is 3x plus 6 over 10 minus, when I do 5 times 1x, I get 5x over 10 equals 2 times 2x is 4x over 10 plus 66 over 10. And if you notice, all the denominators are the same. So I'm going to do the same thing we did in the last section with complex fractions. If all the denominators are the same, then you can drop that thing. All right, you can drop it off. So I say drop that thing with the A. And what I'm referring to is what I have highlighted. So I'm going to drop all those denominators off. So I'm going to rewrite the equation without the 10 in the denominator. So that leaves me with 3x plus 6 minus 5x equals 4x plus 66. All right. And really what you're doing, so mathematically, outside of drop that thing, what you're really doing is you're multiplying every single fraction by 10, the least common denominator. And then when you do that, you end up with this equation at this point. All right, so of course in the textbook they're not going to say drop that thing, but that's basically what it boils down to. So here I'm going to combine like terms. 3x minus 5x is a negative 2x. Then I have that plus 6 behind it equals 4x plus 66. At this point, again, I'm trying to get x by itself. So I'm going to subtract 4x from both sides. Negative 2x minus 4x is negative 6x. Bring down the plus 6. The 4x cancels out, and I have a 66 here. Now I'm going to subtract 6 from both sides. So this leaves you with negative 6x equals 60. Then when I get to this step, I want to get x by itself, so I'm going to divide both sides by negative 6. So x equals negative 10. All right. Next, we're going to talk about classifying equations. So you have 3 types of equations. You have an identity equation, a conditional equation, or inconsistent equation. And they all depend on what type of solution that you get in your final answer. So we're going to run into all three cases in this next example. So we're going to solve these equations just like we did before. The goal is to get x by itself. So in this first equation, I'm going to subtract 4x from both sides. And when I do that, 6x minus 4x is 2x minus 9 equals 13. Then I'm going to add 9 to both sides. So that's 2x equals 22. And then when I divide both sides by 2, I get x equals 11. Because I get an answer, just like we did in the last two examples, because I actually get a number, my final answer is x equals 11. These types of equations that we run into the most often are called conditional equations. So this is a conditional equation. All right, moving on to the next example. Here I'm going to have to distribute the 7 to that parentheses. So I get 10 plus 14x equals 14x minus 35. So now again, my goal is to get x by itself. So I'm going to subtract 14x from both sides. And then look what happens. When I subtract 14x, they actually cancel out both sides. So I no longer have x in the picture. I'm left down to just 10. My equal sign in the middle equals negative 35. So when you get to this point, any type of equation, you get to a point where you don't have x anymore, you get down to this final statement, and you have to ask yourself, is this a true or a false statement? Does 10 actually equal negative 35? And the answer would be no. So since the answer is no, the answer is no solution. The symbol for no solution is a circle with a line through it. So in my math lab, when you see that symbol, that means no solution. Any type of equation that has no solution as the answer is considered or called an inconsistent equation. So this is an inconsistent equation. All right, and then this last equation in this section, I'm going to distribute this negative 3 to this parentheses, and this gives me negative 6x plus 3. Then I have that plus 5x behind it, which is 3 minus x. Combined like terms, negative 6x and negative 5x added together is negative 1x. Then I have a plus 3 equals 3 minus x. My goal is to add x to both sides. I want to get rid of x, so I'm going to add x to both sides so it cancels out. But if you notice, it cancels out on both sides. And so what I'm left with is just a 3 on the left side and a 3 on the right side. So again, you have to ask yourself, is this a true statement? Does 3 actually equal 3? And the answer is that this is true. All right, so this will be, yes, this is true. So since it's true, that means that the answer is all real numbers. All right, that's the solution. So you will click the box that says all real numbers. Any type of equation that has all real numbers as a solution, these are called identity equations. So this is an identity equation. And what all real numbers means, that means I can pull any number I want to out of the sky, plug it in for x, and I'm going to get a true statement. So let me just randomly select the number. All right, let me just say that x equals 2. So I'm telling you that x can equal 2 for this equation. So if this is true, that means if I plug in 2 for x, then both sides should match up. So what I'm going to do is I'm going to come over here and write down negative 3 times 2. I'm going to replace x. I'm going to leave that blank for right now, minus 1. Plus 5 parentheses equals 3 minus parentheses. So I rewrote the equation without x, and I'm telling you that I think the answer is x equals 2. And I just randomly selected a number. I'm putting in a 2. All right. So when I simplify this, I get negative 3. 2 times 2 is 4. So this is 4 minus 1. Plus 5 times 2 is 10. Equals 3 minus 2, which is 1. So then I get negative 3 times, inside the parentheses, 4 minus 1 is 3. Plus 10 equals 1. Negative 3 times 3 is negative 9. Plus 10 equals 1. And look there, negative 9 plus 10 is 1. And 1 equals 1. So 2 is definitely a solution. And that works for any number that you choose for x. So that's what it means that when I say x, when I say the solution is all real numbers, that means it can be any number. All right, this part right here just summarizes. It just summarizes what we did earlier. It says if solving a linear equation leads to a true statement such as 0 equals 0, the equation is an identity. Its solution set is all real numbers. And this is example 3C that we just finished. If solving a linear equation leads to a single solution such as x equals 3, the equation is conditional. And in this case, its solution set consists of x equals 3. So that was the first example. And then it says if solving a linear equation leads to a false statement such as negative 3 equals 7, the equation is inconsistent. Its solution set is no solution. The circle with the line through it. Alrighty. Moving right along. This is solving equations with rational expressions. So basically, these are going to be equations that has an x in a denominator. And because you have a variable in your denominator, you're going to have restrictions. So this kind of goes back to our last lesson when we did rational expressions. Automatically, when I start seeing these equations, the first thing I need to do is write down what x can equal. In this case, x cannot equal 0, because if that denominator equals 0, then it's undefined. So what this means is I'm going to kind of keep this in the back of my mind. I'm going to solve this equation. If I get x equals 0 as an answer, I have to toss it out. And when you're doing your work in my math lab, they're going to ask you for the restrictions. So this would be the restriction. All right, this is what x can't equal. And I'm going to do the same thing that I did before. I'm going to get all my denominators to look exactly like. I'm going to write the problem over because I write a little bigger. So I want all my denominators to look alike. So when you look at the first denominator, you see x. Well, I need to put an x in the other two denominators. But if I put an x in the bottom of this denominator, meaning I'm multiplying the denominator by x, I have to multiply the top by x. When I get to the 6, I need to put an x beside it. And because I put one at the bottom, I need to put one at the top. Then I start looking at the numbers. I see a 2 and a 6. Well, the least common denominator, right, the smallest number that both 2 and 6 can divide into would be 6. So I want all my denominators to have a 6. So this would be a 6 here. So that means I need to multiply the top of this fraction by 6. Well, if I multiply 2 times 3, that becomes 6. So I need to multiply the top by 3 also. And then the last denominator already has a 6. So if I clean this up, I get 12 over 6x plus 3x over 6x equals 7x over 6x. And because all your denominators are the same, you can drop that thing. What's that thing? That thing is the denominators. So I'm going to rewrite the problem without the yellow stuff or the highlighted stuff. So this is 12 plus 3x equals 7x. And this equation looks much nicer than what we had before. So now I'm going to subtract 3x from both sides. And the reason why I'm doing this is because I already have x over here by itself. The 7x doesn't have a number behind it. So I'm going to subtract 3x from this side, from the left side, so I can only have 12 left over. All right, and when I do that, I get 12 equals 7x minus 3x is 4x. I'm going to divide both sides by 4. And when I do that, I get x equals 3. You need to check to make sure that it's not in your restriction box. If it's not, then you're good to go. This will be your solution. If that was in my restriction box, then I will have to toss it out as an answer. Let me see. Ready? All right, looking at the next example. I want to get all my denominators to be the same, but before I do that, I need to get my restrictions. To get your restrictions, you have an x plus 4 in the denominator, so you would say, for my restrictions, x plus 4 cannot equal 0. So you will subtract 4 from both sides, so that means x cannot equal -4. So this would be in your restriction box. So that's half credit right here for the problem, just knowing the restrictions. So I'm going to rewrite it again. 3x over x plus 4 equals 4 over x plus 4 minus 5. My goal is to get all my denominators to look alike. The first two denominators have an x plus 4. So you can make any number a fraction by putting it over 1. So basically I rewrote the fraction, the 5, as like a 5 over 1. And what I'm going to do is I'm going to put an x plus 4 in the denominator. And if I put 1 in the denominator, I have to put it in the numerator. So now that all my denominators are the same, then I drop it. All right, so drop that thing. That thing is the yellow stuff that I highlighted. So now I'm going to rewrite the problem without that denominator. So 3x equals 4. There's a minus sign. There's a 5, and there's an x plus 4. So this is 3x equals 4 minus, I need to distribute this -5 to this parentheses. So this is actually a minus 5x minus 20. Combine like terms. So I get 3x equals -5x minus 16. Add 5x to both sides. 3x plus 5x is 8x. 8x equals -16. Divide both sides by 8. So x equals -2. That's your solution. You have to double check Make sure that it's not your restriction, which in this case is not. So we're good to go. All right, that's your final answer. X equals -2. Okay, let's do this next example. So looking at this denominator, I see for my restrictions, or restriction in this case, x minus 1 cannot equal 0. So you will solve that equation, add 1 to both sides. So automatically I know x cannot equal 1. It could be any other number in the world except 1. So I'm going to rewrite this equation as 3 over x minus 1 plus 7 equals 3x over x minus 1. Again, I'm going to make that 7 a fraction by putting it over 1. And since the other two denominators have an x minus 1, I'm going to make this denominator have an x minus 1 by putting it in the bottom, but I also have to put it in the top. So when you do that, you get 3 over x minus 1. Well, I don't have to, let me drop that thing before I do anything else. So now, if you look, all your denominators are the same. They all have an x minus 1. And so now I can drop that. So drop that thing. And that thing that I'm dropping, I'm highlighting in yellow, is the yellow stuff. So I'm going to rewrite the fraction without the yellow stuff. 3 plus 7, parentheses, x minus 1 equals 3x. You need to multiply before you add. So you bring down a 3 and you distribute the 7. So you don't add the 3 and the 7. You need to multiply what's inside the parentheses by 7. So this becomes 3 plus 7x minus 7 equals 3x. Combine like terms, so this is 7x minus 4 equals 3x. Again, if you look at this problem, I have x over here by itself. So I'm going to subtract 7x from both sides. So that I have -4 equals 3x minus, this is minus. Let me see if I can erase that little extra piece. I don't want that line to confuse you. I'm not dividing. I was just highlighting it. So I'm going to subtract 7x. So I get -4 equals -4x. Divide both sides by -4. So that means 1 equals x, or x equals 1. But when you look up, x cannot equal 1. So you have to toss out that answer. So since you don't have anything else left as an answer, your answer would be a no solution. This equation has no solution. We did all that work and there's no solution. And the symbol for no solution is the circle with the line through it. All right. I'm going to do one more example. I'm going to do example 4. So for example 4, I'm going to do the same thing. I want all my denominators to be the same. So I'm going to rewrite this as x over 1 minus 8 over x minus 4 equals this negative. You can put it right beside the 2x at the top over x minus 4. We want all our denominators to be the same. So I'm going to put an x minus 4 in this denominator. All right, let me move this out the way so I can move it over some. So I multiply the bottom by x minus 4. I have to multiply the top by x minus 4. And now that they all have the same denominator, I can drop that thing. Drop that thing. That thing is what I highlighted in green in this example. So I'm going to rewrite the equation without the denominator. Before I do that, all right, I kind of went a little bit too fast. Remember, you always get your restrictions first. So I should have started from the beginning and wrote down my restrictions. And you want to do that first. In this case, x minus 4 cannot equal 0. When you solve that, add 4 to both sides. So x cannot equal 4. So now I'm going to drop that thing. So I have x times x minus 4 minus 8 equals negative 2x. I'm going to distribute this. X times x is x squared minus 4x. And you have that minus 8 behind it equals negative 2x. As soon as you start seeing x squareds pop up, you want to keep everything on one side of the equation. You want it to be set equal to 0 so that you can factor it and then solve for x. So what I'm going to do in this step, I'm going to add 2x to both sides. So if I add 2x, over here I have to add a 2x on the other side, and you want to add it to the 4x because they're like terms. So this is x squared minus 4x added to 2x, or negative 4x added to 2x is negative 2x. And you have a minus 8 behind it equals 0. At this point, you want to factor. Right? So when I factor on this side, x squared breaks down into x times x. I'm looking for two numbers that multiply and give me a negative 8, but add and give me a negative 2. So that would be a negative 4 times a positive 2. Because negative 4 times positive 2 is negative 8, and negative 4 plus 2 is negative 2. At this point, we need to solve. To solve, you set each parentheses equal to 0, and then you solve. So I add 4 to both sides. X equals 4. And then I subtract 2 from both sides. X equals negative 2. If you notice, x cannot equal 4. So you have to toss out that solution. So your only answer would be x equals negative 2. That's the only solution to this problem. All right. I said I would do, that was the last one, but I think I'm going to do one more. We're going to do example 6, and we'll call it night. All right, so here, before I do anything, I want to factor my denominator. So I need to factor this. So this is 18 over x squared minus 9 factors as a difference of squares. It is a difference of two squares. So this becomes x minus 3 times x plus 3. So go back and look at your notes on difference of squares. But you need to recognize those, and that's how it factors. Equals x over x plus 3. I'm putting a parentheses around it. Minus 3. And I'm going to make it 3 over 1 because everything should be a fraction. And now I need to make sure all my denominators look alike. So if you look in this first denominator, it has an x minus 3 and an x plus 3. And over here, I only have an x plus 3. So I need to put down x minus 3, top and bottom. Over here, I'm missing both x minus 3, x plus 3. So at the top, x minus 3, x plus 3. Okay, trying to understand my fraction bars. And at this point, we're going to drop that thing. So drop that thing. So when I drop that thing, I have 18 equals x times x minus 3 minus 3 times x minus 3 times x plus 3. So now I need to multiply this stuff out. I have 18 equals, distribute this x. X times x is x squared. X times negative 3 is negative 3x. Minus 3. I can go ahead and multiply these two parentheses together, because if you notice in the beginning of the problem, when I had to factor x squared, when I had to factor x squared minus 9, it factored as the x minus 3 times x plus 3. So when I multiply it back together, that x plus 3 times x minus 3 is just going to multiply as x squared minus 9. All right, so kind of went back and put it back in its original form. So now this is 18 equals, oh, I forgot something. We forgot our restrictions. Before we start doing anything, we should do our restrictions, so don't make that same mistake. So going back to the fractions, if you look at all your denominators, you actually have two restrictions in this example. You have x minus 3, that can't equal 0, and x plus 3 cannot equal 0. So when I solve this, I add 3 to both sides. X cannot equal 3. Subtract 3 from both sides. X cannot equal negative 3. These are the two values that x can't equal. All right, so going back to solving the equation, 18 equals x squared minus 3x. Distribute this negative 3. So this is negative 3x squared plus 27. Then I want to combine like terms. So when I do that, negative 3x squared and negative x squared becomes negative 2x squared minus 3x plus 27. I still have that 18 there. At this point, you want to get everything on one side. You want it to be set equal to 0. So I'm going to subtract 18 from both sides. So 0 equals negative 2x squared minus 3x plus 27 minus 18 is 9. When you factor, you do not want your leading coefficient or that first number to be negative. So what I'm going to do is I can multiply or change the signs of everything. So really what I'm going to do is I'm going to take this equation and I'm going to multiply. Let me use a different color. As long as you do it to both sides of the equation, I'm going to multiply both sides of the equation by negative 1. That way I can get rid of that negative in front of the 2x squared. So negative 1 times 0 is just 0. Negative 1 times negative 2x squared is positive 2x squared. Negative 1 times negative 3x is positive 3x. And negative 1 times 9 is negative 9. So basically, you can change the signs of an equation as long as you change the sign of every single term. All right, that's basically what I did. So I changed the signs of everything. All right, the opposite of 0 is just 0. And now we're down to factoring. We're going to use slide and divide. I'm going to take this 2, move it on down here at the end, and multiply it times 9. So this is 2. So that'd be 2. So this gives me x squared plus 3x minus 18. I need to factor this. So this is x and x. I need two numbers that multiply and give me negative 18, but add and give me positive 3. So this would be positive 6 and negative 3. And then remember, you have to come back and undo what you did. We multiplied by 2, so now we have to divide by 2. So this becomes x plus 3 times x minus 3 over 2. And I'm solving. So at this point, you don't have to put the 2 in front of the x. Yes, if you were factoring, that would be the next step. But since you're solving, the easiest thing to do is keep it in this form as x plus 3 equals 0 and x minus 3 over 2 equals 0. If you do that, you subtract 3 from both sides. You get x equals negative 3. Here, if I add 3 over 2 to both sides, it's just a one-step equation. It's the opposite. So x equals positive 3 over 2. If you didn't like doing it that way, like leaving it as a fraction, if you want to go the whole extra step and actually write it in factor form, it would be x plus 6 times 2x minus 3 equals 0. Not x plus 6, but at this step here, let me go back. Let me erase this. At this step, when I divided by 2, this would have been x plus 3. And then you had that x minus 3 over 2. So the 2 comes in front of the x. So you would get 2x minus 3. And we already solved this. We did x plus 3 equals 0. Now I could do 2x minus 3 equals 0. And if you solve it in this form, you should get the same answer. Add 3 to both sides. So you have 2x equals 3. Divide both sides by 2. X equals 3 over 2. So since you're solving, you don't have to do that last step with factoring, but if you're comfortable or you're used to factoring all the way down, then do that and you'll get the same answer. So I still get x equals 3 over 2. And of course, if I come over here and subtract 3 from both sides, x equals negative 3. But remember, in the beginning, x can't equal negative 3. So that means I have to toss out that solution. So your only solution to this problem is x equals 3 over 2. All right. So that's your first section in this unit. This unit is called equations. We're going to run into, we're going to learn how to solve different types of equations. And so today we learn how to solve linear equations, and we learn how to solve equations with variables in the denominator, rational equations. All right, that's it.